Now again we are having a very important result, okay, for the inverse part. Although you are already aware for this result in the transpose, okay, we have done in the transpose, that transpose of this side, left hand side. Similarly we written transpose of AB is equal to transpose of B multiplied by transpose of A. Now we are in the inverse. So what our theorem says, if A and B are invertible matrices of order n, then show that AB is invertible. Okay, first of all we have to show that AB is invertible, and when AB is invertible, then AB inverse is equal to B inverse A inverse. Okay, and this is a very important result. I am just going to write something here, and this is AB inverse is equal to B inverse A inverse, and sometimes it is also called, it is called reversal law of inverse, reversal law of inverse of product of matrices. Okay, so this is also called this thing. Now let's prove it. Now it is already given that A and B are invertible. Okay, so A and B are invertible matrices. Now this is given. This is given to us. A and B are invertible matrices. Then when A and B are invertible matrices, we can say A inverse and B inverse exists. A inverse and B inverse exists when A and B are invertible matrices. Then what we can write it? We can write it now. Therefore, A with A inverse is equal to A inverse with A is equal to identity matrix, and we can write it B with B inverse is equal to B inverse B is equal to identity matrix. Okay, so we can write it when it is already given in the statement, that in the theorem that A and B are invertible matrices. When A and B are invertible, then we can write with this condition. Hence AB is defined. Okay, when A and B are invertible, we can say we have defined AB. Okay, so we can write it, hence AB is defined. Okay, hence AB is defined. Now what we are having, determinant of AB is equal to determinant of A with determinant of B, and this is not equal to 0 because A and B are invertible. Reason? Because A and B are invertible. Okay, because A and B are invertible. Now this shows what? Neither of A and neither of B are 0. Okay, so we can write determinant of A is not equal to 0, determinant of B is not equal to 0. Okay, so this shows AB is invertible. Therefore, AB is invertible, and when AB is invertible, then inverse of AB exists. Then inverse of AB exists. Okay, so this was first of all very simple thing we have done, that AB is invertible. Okay, now we are having, now according to the definition, we suppose we are having PQ is equal to QR is equal to IN. Okay, by definition of inverse. By definition of inverse, and PQ and P and Q are square matrices. Okay, P and Q are square non-singular matrix. Is it clear? Now let P is equal to AB and Q is equal to B inverse A inverse. Okay, P is equal to AB and Q is equal to B inverse A inverse. Now we are having AB with B inverse A inverse is equal to, now AB with B inverse A inverse is equal to B inverse A inverse with AB. Okay, according to the definition, and this is equal to what? This is equal to I. Now let's move with the left hand side first. Okay, now left hand side. Left hand side, what we are having? AB with B inverse A inverse. Now this can be written as A, B, B inverse A inverse. Further, this can be written as A with IN with A inverse, and this is equal to A inverse and this is equal to IN. Okay, now what the conditions we have used? B inverse is equal to IN and AIN is equal to A. Okay, or you can say or IN with A inverse is equal to A inverse. So we have used these things, this one. Okay, so left hand side is equal to IN. Now for the right hand side, right hand side is B inverse A inverse with AB is equal to B inverse A with B. This is equal to B inverse IN with B, and this is equal to B inverse B, and again this is equal to IN. Okay, so now from this part what we are getting, that PQ is equal to QR is equal to IN. Okay, hence when P and Q, it means P is the inverse of Q or Q is the inverse of P. Okay, so we can write it, hence P inverse is equal to Q, or we can say AB inverse is equal to B inverse A inverse. So this is proved. Okay, so a very nice theorem, and easily we can go through the concept, and we will be having number of questions. We are going to solve number of questions based on this result. Okay, we are having a very important question on these results. Okay.